Okay, so I'm going to talk about both models and data models for interoperability for citizen science. And I'll give an introduction to the concept of citizens observatories in citizen science with the Citizens Project as a basis, and the work we do on an interoperability reference model for citizen science, which is rooted on the European Interoperability Framework, ISO NIST Big Data Interoperability Framework, and reflections we have done in these projects, and also relationship to work in the GEOSS context and the European Citizen Science Association. So that's the topic I will touch upon. And I'll start to mention that we have currently a set of projects, Citizens for Air Quality Monitoring, development on sensor-based Citizens Observatory for improving quality of life in cities is the one I'm working on. You see down to the right here other projects we heard earlier from Cobweb and OGC participation with Bart in this series this week. We have also...
Arne,
yep.
Sorry to interrupt, but I think we are just seeing your first slide on the screen. So I think you have to change to the to a different mode of...
Yes, okay, it's because I was changing my slides and you don't see that. Let me see how I can do that. Change it in a different way, perhaps, if I can share my whole screen in a suitable way. Let's see how to do that. Let me share my entire screen. Okay, so do you see my whole screen now?
We see still a video. So I think you have to open a different window and then put your presentation there in presentation mode.
Okay, let's see there. The right one stored here.
Now we see it. Well.
Do you see it now?
We see several screens.
Okay, and now you see
there
one?
Yes. Yes.
Okay. Okay, so let's stay on that one.
Okay, here we go.
Now you should see on the lower right-hand side the number of project names, which are the 5 Citizens Observatory projects that have been running in Europe for the last 3 years, and going into the last year. Some of them finished already, but CITI-SENSE and vSensit and Cobweb is still running. And we are now looking at common technology aspects for future activities. I represent the CITI-SENSE on air quality. We heard also Cobweb working on biodiversity and aspects related to observations in nature, which is very relevant for the Hepatica week. But what's been pointed out during earlier session this week is that there is a lot of commonalities if you look now into the interoperability aspects of these systems that are supporting our activities. So what we see here is the Citizens Platform, and on top we see basically a common structure or life cycle that starts with managing all of the resources, the citizens or the humans, the sensors, the data and the services we have. And the main focus is on observations, static or mobile observations, also dealing with surveys with questions. And then the process goes further on to publish or make this observation available, doing discovery of these, and also doing various kind of analysis, validation and verification, and doing something further based on it. So what we typically have is a situation where there's a lot of different input opportunities, mobile apps, but also web portals with surveys and questionnaires, also static sensors or mobile sensors that are interacting to provide additional information for the observations, and then storage facilities where we have a special data service platform in CITI-SENSE that used OGC standards, WFS for storage of observation, and provide the output of this in different ways, including linked data. And then we are looking into how to make all of these resources available in the GEOSS common infrastructure for relevant resources about environmental observation. And this is a common, pattern that we have in a lot of these activities that we are talking about this week. There are differences in terms of the actual implementations of this, but the principle is common. So based on that, we have looked into a kind of common citizen science reference model, trying to identify the common aspects and what we can share, and how we can also support interoperability in terms of sharing the outcomes of observations for various purposes. And for this, this reference model puts a kind of broad context on what we are doing with an overall information value chain based on the life cycle of observation related to ISO 19119 standard, where I have a responsibility, and also Inspire for spatial data infrastructure. And then adopting concepts from the European Interoperability Framework, looking at various aspects of interoperability with the lowest level of technical interoperability, and also linked to non-functional aspects. So I'll say a few words about this, and starting out with the overall life cycle that we have from the work in Inspire and ISO 19119, and bring this into the context of this Hepatica week, where we will look into observations of flowers, which is the focus of the observations. But the general aspect we have is that we have some way of managing want to complete this first. Well, managing observations, registering users, discovery observations, viewing observations, and making these available for various kind of analysis purposes. So with this perspective that we will go from observations being done to being managed and identified, we can look into the broader concepts of interoperability, which means resolving the issues when we want things to work together. And it's not only data that will interoperate, but it's the wider context. So we need also to look into the political context of why do we want to have interoperability, the legal aspects of interoperability with laws, and also with ownership, and with issues dealing with privacy. Part of this is organizational interoperability. What are the agreements between organizations and individuals? Semantic interoperability, dealing with the meaning of things that we are interchanging. And technical interoperability, how do we do this from a technical implementation point of view? So this European Interoperability Framework is a nice broader context when we talk about interoperability. And we need actually to address all of these levels in a broad context. From the technical point of view, we can look at the ISO 19119 service architecture model, which is also used in OGC, with a number of topics that we need to address if we look into the technology aspects of interoperability. We have put it into the context of citizens observatory elements, and we talk about boundary and interaction services, which are where the sensors and the user interfaces comes in. We have the data and things sensor management services, dealing with data management, where is the main data model is residing. But they have a purpose of being processed, so also the processing services is related to this, and the workflow combination of various services with composition and orchestration services, and this is related again to communication management and security services. So all of these are elements that we need to look into when we talk about interoperability from a technical point of view. There is a similar activity in the current popular buzzword area, I guess, on big data. Here is from the ongoing work with ISO and US National Institute of Standards for a big data interoperability framework. And what's interesting is that we can recognize the same kind of information value chain model here, from data collection, observations in our case, preparation and curation, analytics, visualization, and access. So it's the same life cycle philosophy as we have from Inspire and from the ISO work. And we have an underlying description of data management support from physical resources of data storage, different kind of data representations, batch interactive or streaming handling. So citizen science and citizens observations fits into this framework, and we can follow some of the same principles and also some of the same supporting standards which will evolve from this work. So up to the left here we have the common view of collection, preparing, doing analysis, validation of access to observations. So from that perspective, we have tried to look into the reusable elements for interoperability for future projects, also in the Citizens Observatory projects, and started the work on the Citizens Observatory Toolbox, where the most important parts here is the joint collection of data of different kinds and the storage point into data. So we can gather observation from mobile apps, also activities on doing surveys with questionnaires, handling data from sensors, and then doing the presentation of the data into user interface widgets and portals, and also have methods and guidelines and analytics for how to process the data. So what we are looking at is all of these different elements with respect to finding common facilities. And for interoperability, with the core focusing on the data, there is also a relationship to the usage of this data for both input and output. So we find this in the Citizens Observatory web portal of the Citizens project, where we now are looking into the technology aspects as well as the user aspects from these perspectives. We can actually bring this also into a broader interoperability architecture, and what we see on the top level here is this user interface boundary edge computing facilities of sensors, mobile apps, everything that provides input to the system, with the main goal of ending down in the repository where the observations will be stored and shared and linked and represented in many different forms. But one of the reasons why we want to look at commonalities here is that we can introduce a number of services dealing with the understanding of the concept definitions with ontology observations, how to support the tracking of the actual data use, how to do analysis for changes in terms of sequences of observations in certain areas, how we can deal with visualization, both mobile and web portals, how we can do quality assessment, how we can support species observation identification, how we can introduce social networking and game services, as we had heard about earlier this week, how we can provide notifications of certain events. So there is a number of useful services that can be actually introduced once we have a common representation form that can be shared among a number of systems and services, including processing services for different kind of analytics. And also making it available in different forms. The GEOSS common infrastructure is trying to share environmental observations across a number of areas. So we see that we can actually look at a number of technical elements from the data on the repository level to the processing services, which will link up to the applications. So we have looked into applications earlier this week and how we can actually do observations. And we have also mentioned the approach of looking at common data models. One of the advantages of having interoperable representation is that we can introduce and start to realize a number of services using these data representations eventually in the future. So just a few of these apps that we have been working on that are relevant also for this biodiversity observations app, like biocaching and others we have talked about this week, just to illustrate the commonalities. And here we see from the Citizens project the SENSE app to describe observations of current situations in terms of air quality and other aspects such as acoustic comfort, the thermal index, where a citizen will be on a certain point and report on this. We can see it displayed on a map, and we can provide various kind of inputs together with sensor data that is providing actual measurements. We heard also about the City Air app earlier this week, where users can report on how they feel the situation is in a particular point of view, which is really very similar in principle for doing an observation of any kind, which fits nicely into this week's focus on, say, flower and Hepatica observations. The point is to show the commonalities here, and what we are studying now is the data model behind this, focusing on the observation and the measurements and the various characteristics of an observation. So this is part of the data model from the Citizens project. I will not go into the details of this, but I will just show the ongoing discussions that is happening across a number of projects now. We heard from OGC and BART about the SWE profile for citizen science, which this is part of the discussion for, where again the focus is on the citizen science observations, the observations itself, the time of the observation, the position of the observation, and the associated data that is being collected. And in general, the only thing that is actually different between the observation is the data types of the collection and certain additional information that might be different for different kinds of observation. But there's a lot of things in common that would help us to share data models across a number of observation types. So this is a bit of the details of what these data models look like. It's still not consolidated across a number of disciplines, and that's one of the activities we hope to do this year, to find out what this model will be, so that it actually can both share data across different kind of observation, as well as have the opportunity to capture specialized data, because also all disciplines will have some special additions that will be part of extension here. And this is all needed if you're going to share data in the broader community, particularly with GEOSS. Here we see more detail of the GEOSS common infrastructure and how different community portals, such as Citizens Observatory portals, can play a part of this and provide their observations into the broader community. We need also, in order to support semantic interoperability, to understand the meaning of the things that we observe and that we share, to be able to have common definitions of what is an observation, what is the element of an observation, what are the different characteristics that is common among all of these observations. And that means that we in the future will be able to have web portals or access points that provide data in such a way that we not only can look at it, but we can also understand the meaning of the data, because we have a shared underlying common model. So this is just a part of the Citizens Observatory web portal, which looks a little bit on the map to the right from what we can do in the GEOSS portal. And we can go there to identify observations in different areas and retrieve it and present it in different ways. And one of the objectives is to not have just particular portals that are specialized for a certain purpose. They will be there as part of it, but we also want to have this broader community that can share things across. So this is a current activity in the community. I want to mention the European Citizen Science Association as an active part of this. And we also have the American activities called the Citizen Science Association and a similar one in Australia. So these three communities are currently also interoperating in terms of their activities. Just to make a little marketing of the upcoming event of the Citizen Science Conference that will take place in Berlin in May, where there will be focus and presentations and discussions and sessions also on all of these aspects, including the common data models. So that was what I planned to do now, to basically give you this overview of all of these activities around interoperability and common data models and sharing. And this is ongoing activity in the community, where the Hepatica Week actually is an interesting contribution, because it shows one relevant observation type, and it's a good example of data that we would like to share among us in different kind of forms, also introducing these concepts of interoperability and data models, as I gave a kind of high-level overview of now. So here is some of the contact points of the Citizens project and my coordinates. And hope there will be some interested people in the community that will also be part of the future activities, looking at how all of these things can come together to improve the further interoperability of all of the observations that we do. Okay,
thank you. Yeah, thank you so